Yeah, so what we've done, what we're presenting today is the implementation of Keycloak as a reference implementation of an identity service, and then showing a link between a component and the identity service. And we're doing this as a reference implementation, so we're not saying you have to have Keycloak in your canvas. We're saying the canvas should have an identity service, and we're changing the relationship between what is in a component versus what's in a canvas. And so we built a reference implementation based on Keycloak, but you could have your own canvas with your own identity service in it. And effectively that relationship and what a component exposes would be the same. So we'll come on to that a bit later. I'm going to whiz through basically how it works with a bit of an introduction even to how Kubernetes itself works. So effectively we're extending the Kubernetes patterns. So you've seen this before. This is like our definition of a component. And what we're adding now is we're saying, up till now, we've only really had information in the core function. So for the first time, we're exposing from a component information in the security section. And specifically, a component exposes the roles it expects to appear in the identity service. So we're saying a software component shouldn't manage identities. They should be managed in the canvas. So there's a single place where we manage identities. But a component should basically say, to operate me, I'm going to let you have access to the roles that I can implement in my component. And the example component we built is a product catalog component, which is a good example, because then you can imagine there may be lots of different roles of people to have different levels of access to different catalogs. And effectively, the component will expose those using the party role API from TM4, but the canvas will implement the actual identity service. And then this is the picture of the canvas. So the canvas is this whole pink area. And what we're saying is the canvas has all the non-functional services, including the identity service. So we've got a reference implementation of canvas with Keycloak as the identity service, but you could have your own identity service. So actually in Vodafone, we don't use Keycloak. We use Azure Active Directory. So in Vodafone, we could build a Vodafone canvas with Azure Active Directory. And then the thing that links them together is the component exposes this role data, and there's an operator. So the thing we've actually developed over the last few weeks as part of this Sprint 2 is a security operator or security controller, which effectively interprets the metadata from a component and it configures Keycloak. So we've got a Keycloak controller configuring Keycloak. If I was going to build an Azure or have an Azure identity service, you'd have an operator specifically for Azure. So the metadata would be the same, because metadata is saying the intent or the requirement of this component is to have these roles. The operator interprets that. So I could have an Azure operator configuring Azure, or I could have any other, name your identity service of choice. You could build an operator for that identity service and interpret that metadata and then configure that service. But the whole idea of this model is when someone deploys a component, that identity service is completely automatically configured with no human intervention. And then like a human operator can go in and say, I want to give these identities and map them to the roles, but if actually the original configuration of the identity service is completely automated. Let's go with this one. I've just got a couple of slides just showing how Kubernetes works, just to show how this pattern works. So with Kubernetes, when I have any resource, like any of the standard Kubernetes resources that it manages, it's got this intent-based API. It's almost like the most important part for Kubernetes is actually the Kubernetes API. And then when I give it an intent, it actually stores that intent in a etcd data store. So effectively, Kubernetes says, I know what you want. Yeah. How I'm going to deliver that can follow, but first it captures what you actually want. And then in the Kubernetes implementation, there is a controller that then takes the intent and sets out to make the implementation match the intent. So it's like a closed loop control so that the implementation should always match the intent. And if anything goes wrong, like if this pod in this example crashes, the controller will automatically pick it up and say, well, you wanted one, there was one, but it's crashed, I'll go and recreate one pod. And this pattern of having an intent, which is stored in a database, and separately a controller, is effectively the pattern that we're extending to manage resources beyond the base Kubernetes resources. So here's a Kubernetes API, which, like the very basic resource it manages, is a pod, where you say, my intent is I want one pod, it's stored, and the controller says, oh, I'm going to make sure the infrastructure has that one pod deployed. Then there are other resources. So for example, there's a resource called a replica set, where Kubernetes, if you say I want a replica set, you're basically saying, you know, I want 2 pods or 3 pods. And an interesting thing about the replica set is it doesn't actually create any infrastructure. It just basically says, if you create a replica set saying I want 3 pods, this controller will interact back with the Kubernetes API and create 3 pod resources. And then the controller for the pods actually creates the infrastructure changes for those pods. And even in the base Kubernetes, there are some intents and controllers which configure external services. So if you look at an ingress resource in Kubernetes, so there's an intent called an ingress, but actually the implementation of that, the controller for an ingress, will vary depending on your deployment. So if I'm running my Kubernetes on Amazon Web Services, there is an AWS ingress controller, which then configures the Amazon Web Services load balancers, so part of their cloud service. If I was deploying it on GKE, it'd be the same. It'd be a GKE specific controller configuring the GKE load balancer. And if I was doing on bare metal, I might do something like have an Nginx controller configuring Nginx. So even in the base Kubernetes, there are this pattern of having controllers even managing external resources, and effectively that's what we're doing. So the whole notion with the component model is we're saying, let's define a component resource. So we have this custom resource matching that, this picture of this pentagon. So we defined a component custom resource in a YAML definition, which describes an intent, like a component saying, I've got this modular unit of software I want to deploy and manage, independently. And so we take that intent and the component intent gets stored in Kubernetes. We've effectively extended the Kubernetes API. And then we have custom controls which we've developed to take that intent and then go and configure these other services. And the one we've been working on in Sprint 2 is configuring the identity service. But the pattern works the same. So if I was configuring, API gateway, identity service, whatever the service is, this is the pattern that we're following. And this is like a single slide from the action week, where we're saying, the process to create a component is packaging up some existing software into containers, then is adding this metadata. And the metadata, typically, you're adding the standard Kubernetes resources, but then this is an additional resource that we've created called a component resource. And our plan is, we've got this component resource, which is the base resource we're creating. There's, behind the scenes, there's also an API resource. When we describe an API, we've created a custom description for what is, in our view, is an API. And there might be more to follow. So it is you package up this metadata. Then when you test it, we've created a CTK. So for the security validation, we now have a CTK, which is the static and dynamic testing of the security metadata that we're adding. And finally, we can deploy it in this open digital lab. So Brian, you're going to talk to this from this slide on, yeah?
Yes, I am. And so one of the reasons that we picked this is that we need to do a few different things. The first one is we need to make sure that we are integrating security controls right from the beginning of how we do this. It's often something that's bolted on at the end. So we thought, well, let's turn that around and do it from the beginning. At least then we can, we can make sure that we understand what the challenges are doing this. And really the second part of it is that in practical terms, it's we need to do it. We need to make sure that we've got a model that works. works. So go for that first, and then like even if we're not implementing TLS connections and things like that, most services by default require some kind of login. So getting identity sorted out from the beginning is the way to go here. But as doing this, what we wanted to do under the auspices of the TM forum is effectively to use it as an opportunity to experiment and challenge the default model behind identity management that we have at the moment, which tends to be, yes, there's a corporate identity management system, but a whole bunch of stuff is duplicated inside different components and different pieces of software, often in different ways, managed by different teams. There's a lot of duplication of effort, and frankly, stuff falls off all the time inside service providers. So somebody leaves the organization and there isn't a clear way of mapping that back to an individual piece of software, and therefore identities are their life is prolonged after the point where it should have been stopped. So we're changing it as an experiment here, and what we're trying to do is we're trying to say, well, if you look at the kind of zero trust models that we're putting in place in most organizations at the moment, really it relies on creating the smallest trust perimeter that you can, and making sure that you're clear who owns what part of the data model and how that's managed. And we believe that for this model, for the canvas and components model on the ODA CA, the right answer is for everything to do with an individual's identity to be managed centrally by the identity management solution, creation of users, creation of groups of users, and those kinds of things. But the existence of an individual role which a user or group of users could pick up, actually that should sit within the component. That validly should sit there, because effectively what you have is you have a set of permissions that can be assigned to a role, and the interpretation of what those permissions means, again, is best done within a component. So the model that we got here is this: we create roles inside components. For the purposes of this, we're recommending that we use the party role management API within the TM forum open API set, simply because it's there and it does what we need it to do, and we can test the pros and cons of doing that. And we're then going to use, as Lester said, this idea of a security controller to connect what happens with roles inside a component with what should be available for the identity management team to assign to their users. So let's go to the next slide, please. You could, Lester, are we going to make these slides available, or are they already available?
Yeah.
Yeah. Right, okay. So you can read this in your own time, but effectively what we're saying here is we have an operations team who is responsible for installing and creating a product catalog or uninstalling a product catalog component that we're going to demonstrate. At the point where that product catalog component is created, or any other component is created, we effectively want the security controller inside the canvas to be able to pick that up, integrate that component with the identity management solution, and then enable the creation of roles according to whatever happens within the product catalog component, or whatever component. And then at the point where a user comes along and tries to access it, then we have the integration of the identity with the role, and so on and so forth. On the next slide is exactly the same thing, but we've always cut and replaced Azure AD and Keycloak, because actually in Vodafone we would probably test this against Azure AD, and what we've done so far is we've actually identified how we would create the security controller to do that. We haven't actually done it yet, but we've identified the APIs and how we're going to call the APIs in Azure AD that would allow us to do exactly the same thing. The key point on this diagram is that the product catalog component part, the operations part, the catalog admin part, none of that has actually changed. And then on the next slide, is the next slide? No, it's not. So what we're concentrating on here is a particular concept in what we've created so far, and really at the moment we're looking at because it's easier. Is how do you get an individual user onto a portal where that portal is hosted in the canvas somehow. Standard OAuth stuff in this example. An unauthenticated user accesses a portal. The identities that's redirected to the identity service, which manages the authentication of the user and the provision of a token with the roles that user has available to it across multiple different systems. At which point, then you go back to the portal. The portal itself can verify the token, and then access is permitted on the basis of the roles that are listed in a verified token. Again, part of this piece of work is going to be to agree the parts of the schema of like JavaScript web tokens that are used and how they're used, because it happens differently from system to system at the moment, and you know, we may need to choose a particular structure and format of the data model for the JWTs. And I think my next slide is probably the demo, isn't it? Right, here we go. If I can share my screen. Can I share my screen?
You'll be able to, yeah.
I should be able to share my screen, right? Let me do that then. So if I share that screen there, hey, look at that, that was quick. Right. So this is I'm here at home. This is running on my own personal network. What I actually have here is I have a 3-node Kubernetes cluster. It's already running a copy of the canvas. It's already running the security controller. As you can see, it's already running Keycloak as well. All of these charts and things, by the way, I've just raised PRs in the team from GitHub to make sure that all of this is available and visible to those who have access to the various repositories. And then effectively, what I'm going to do now is, if I just sign into Keycloak for a minute and show you a little bit about the interface to Keycloak. In your organization, whatever organization you're in, so ours is Vodafone, Keycloak has this concept of a realm. So in Vodafone terms, the realm would be Vodafone, whatever you want to call it. But effectively, a realm defines a group of users. So in Vodafone, that's everybody. And then within the concept of a realm in Keycloak, which would be the organization, you have this concept of a client, and the mapping for us here is that client equals component. So if you create a component, there should be a matching client. And again, if you go into any particular client, it doesn't matter which one because they're all the same. Inside a client, there is a concept of a client role. This one has none, but I don't think, maybe it's got some default ones. So look, no, nothing. But effectively, then you have this hierarchy of, within my organization, my realm, I have a list of components. Those are my clients, and each of those components, each of those clients can have its own roles. And then on the other side of it in Keycloak, you can have users and groups of users, and you can assign these roles at the client level to groups of users or individual users. So you can see in the Keycloak model of things, and Azure AD is not far different, you would effectively have all of your users in a realm. All of those users would be members of groups according to what their job role is inside the organization. So, maybe they're junior contact center agents or senior contact center agents, or, architects or whatever they are. And then we also start building out these lists of clients, there's a list of components, and you can then assign roles to those groups of people. So you can see if I'm a contact center agent, I'm in a group of contact center agents, and the contact center agent group has a role assigned to it, which might be, read access to a product catalog, for example. So at the moment, the bit that I really wanted to show you here is, if I go back to the clients list, at the moment, that's all the set of clients that I have listed in a realm, which I've just called my realm, because that's what it's called in the Keycloak demos. In this example, what we're actually going to do is, I'm going to deploy a product catalog component. And here it's called, here I'm giving it the name R1. We use Helm to install it. It's a very, very simple install. Helm install, give it the name of the component, namespace, give it a name which I called R1 for the release, and then the dot at the end says actually the chance for this in the current folder. So if I deploy that, that's going to start its run through through Kubernetes to raise that, and at some point the component controller will declare that the component itself is ready, and at the point where the component controller decides, at the point where the component exposes the correct APIs and responds to a readiness probe inside Kubernetes, the component operator will say, yep, this is ready, at which point the security controller will pick it up and go, right, I'm going to call the party role API, and as a very minimum, what I'm going to do is, and this is a blue Peter moment here, yeah, not yet, it's going to then create a
client.
It's going to create a client. That does take a few minutes. I was hoping it would have been done by now, but presumably it's pulling down some new. I'll have to go and have a look at this and find out what's going on. Let me just see if it's actually running at the moment. Yeah, service unavailable. So it's still not running. The component doesn't say it's ready yet. In fact, I can probably see that. I log into the dashboard and show you. Spaces. Let's have a look. Make sure it hasn't actually failed. Yeah, so it's there and running now. If I look in here, I'm hoping that this is going to give me. So they're up and running, and yeah, actually I have a URL for them, so that should be working now. If I go back to the admin console with any luck, I can refresh this. And we do, there, here we go. So R1 product catalog, you can see there I now have a client. So that client now is available to have roles associated with it. At the moment, it has none. Click view all roles, there are none. But now I have the ability here, if I go to Postman just to test the front end API, if I just hit send on there. So that's me asking the party role in that product catalog for a list of roles. None exist right now. What I can do is I can go and I can create a new party role.
This would be someone who's in like the product catalog team.
Yeah.
Effectively, will be doing this. Yeah.
Yeah. So at the point where I decide to administer the product catalog component, not the product catalog itself, I would have a product catalog component administrator who would be able to go in and create roles. That might be automated. I'm actually calling the party role management API rather than going into some kind of portal here. Andy, can you give me a word or a phrase that I can use as a name, just so we can show that this is not not rigged. Okay. A name for a role. It can be anything.
A name for a role. Okay. Okay. Let's call it super catalog user or something.
Super catalog user. Will that do?
Yeah.
Right. Okay. So if I hit send, then I've now, according to the component, it now has a role of super catalog user. If I call get party roles again, I should now see I now have a single role in there called super catalog user. If I go back to Keycloak and hit refresh, my heart's beating really hard at this point, but I now have super catalog user in my Keycloak. So that role now is available in the identity management platform to be assigned to a group of users. And again, I can, as long as I'm registered to the list, as long as my security controller is registered to the listener of the component, which in this case it is, then effectively I get real-time adds and deletes of roles. So as the component administrators themselves decide that new roles are required or old roles are obsolete now, we can automatically synchronize those changes with the identity management platform. at the point where a user then wants to access in this case, the product catalog, they would be authenticated against Keycloak. Keycloak would assign them a token that says, against this R1 product catalog component, you have the role of super catalog user. And then it would be down to the component to say, I recognize that this person has been validly authenticated. I recognize that this person has an authentic token, and I see that they have the role of super catalog user against myself, and therefore access granted. And that's kind of where we're heading. We're going to try and make this available in the ODA CA rancher environment shortly. And like I say, all of the code behind this is currently checked in with a PR waiting for.
Yeah, so we've actually got 4 pull requests. So there's the source code of the controller, which is the security controller written in Python. Then there is like the canvas Helm charts. So when you deploy the canvas chart now, it deploys Keycloak and it deploys this controller and sets it all up for you. We've created a sample component which implements this new security feature. So there is an example, and we put that in the documentation repository. So there's like a sample component which is a product catalog, and it has this party role API as well, so you can manage it. And then there's a CTK. So the CTK, and it's now version aware, so you can still test sort of release 1 components with CTK, and it'll do the same set of tests as we had in the sprint 1. But now if you self-declare as being a version 2 of the component definition, it'll also test for the security metadata. And then the dynamic test will actually test that it has a party role API, and actually test you've got at least 1 role in that party role API. So there's 4 different pull requests which we are proposing as part of this. And I'd say it's not like this work isn't finished. Like we've got the end-to-end scenario working. There is still we've got a backlog of minor things which we think we should improve on and tidy up on. But our plan was to, if everyone's in agreement, our plan was to actually merge these into the master branch, and it shouldn't interfere with the previous versions because it is now version aware between these 2 different versions. So things should, it's good test, things should carry on working even though there were components designed for the version 1. And then we will do it at a later stage. We will pull all the updates of improvements and tweaks that we make to it.
Am I right?
And remove all the bodges that I put in there, right? Yeah. By the way, do not run my code in production.
Yeah. So Brian, you created super catalog user there, and if I understood the concept, the actual permissions assigned to super catalog user will be defined in the product catalog component. Is that correct?
Yes.
So what is the link between the super catalog user and a user in the component? How is that sort of set up?
Yeah, so what we're trying to do is we're trying to provide a very, very clear separation of concerns between what happens in the component and what happens in identity management. So all aspects of identity management should be the domain of the identity management platform. All aspects of authorization against all responsibility for assigning permissions to roles should happen within the component. And then who gets to do what job is also an identity management concern. In fact, it's an HR concern more than anything. It's like who's in which team, and therefore, which groups are they part of is effectively an HR concern. So the link between, and again, this is part of the test and part of the proposal, is that the link between you as a person, Andy, and you as a super catalog user is that you as a person gains your list of roles as part of the group that you're a member of, as part of identity management, and your authentication happens there. But effectively, the roles that you have are included in the JWT token that you're issued, or the JWT that you're issued with at the point of authentication. There is no part of your identity, you as a person, that should sit within these components. In that product catalog component that we've created, the only thing that it does is read your list of roles from your token. Yeah, and it also, in fact, it also reads your name from the token and a few other things as well. So the component can know who you are, but that information is gathered from the token itself.
Good. Okay, and so you said you've got a little bit more work to do before this is sort of available, deployed, and the documentation there. But
it should be available. Like, it's available. Our plan is to merge it. We've issued this pull request. Our plan is to merge it in because it's like fully working. There's just like some tweaks and improvements that we think we should make to it. But like in a sort of an agile approach, our plan was merge this into the master branch. People can test components against it now, and test the CDKs. Like, it is all working. But yeah, we will do some tweaks and updates. Some which should be non-breaking updates between now and the end of the sprint.
Yeah, it works, and that's what we're raising a PR against. And then, I know for a fact I've got dodgy comments. I've got workarounds for bugs that are commented out and things. It's all that kind of stuff needs to go. But we just wanted to get it works, and you can try it.
Yeah, it would be good for someone to try it on their own component.
yes, so that's, I think, so we've got 3 weeks now till the show and tell, and our idea is that we, rather like the last one, we would show some real world components modified to use the security approach, and passing the using the CTK and passing the tests as valid, as validated. So that, I guess, it would be great if some of the, and it doesn't need to be a product catalog component, right? There's a sort of worked example, but it can be any component. And so if the vendors or anyone with components here can start looking at select a component and see if you can follow the example, and be ready to show your component going through the automated test and hopefully passing. Even failing would be interesting, I suppose, wouldn't it? But anyway, either way, as for the demo, that would be great.
Do we need just a question? Do we need a default set of user roles? Not that it's a fixed enumerated set, but that it includes at least certain things.
That's one thing we're talking about. Yeah, we might need to bootstrap it with a default set.
Yeah, because I know when I bought systems myself, often they come with default roles and profiles in them.
Yeah, and like one of the things that, as Lester said, we're looking at what kind of bootstrap role you might need just to get a component off the ground. And the other thing we're looking at is what should the default behavior of a new component be for those default roles. So the ideal would be, as soon as as soon as the security controller is a registered listener, that effectively the component advertises through that listener all of those predefined roles, however many there are, so they can be populated directly into identity management.
Yeah, we identified this bootstrapping issue as part of the ODA technical architecture, and this is very useful, because we could use these as examples in an update on it.
Maybe we start with a default list of one super
Could be.
and then at least we've then got a mechanism for where do you store your default roles.
The only thing is, from an ODA point of view, you probably need to have the default. You're probably right on the bootstrapping that you use more generally. It's probably just a security requirement or a single role. But when we start to manage the components, there will be sort of like somebody who's managing that component and the data within it, an administrator. And then there'll be some kind of super user, which is what Andy chose as his name, I think. But I think that would be a good discussion about, I think the principle, isn't it, the minimum requirements at the start, zero trust.
Yeah.
So one is probably as small as you can get.
Yeah, and I think the minimum requirement is to bootstrap the component and have the ability to assign roles to users in
Yeah,
your
exactly.
platform. I mean, aside from that, it might be different from component to component or from vendor to vendor. You know, it's like, but the mechanism for, you know, creating and advertising those roles should.
And there could be a good reason to separate those, because you're effectively booting something into the ODA system environment, and then there's the booting up of the component itself to be performing the functions that are necessary within an organization.
Yeah.
If I can give you some pointers, if I share my screen again, hopefully you can see the GitHub repositories, yeah?
Yep.
Yeah, so unless there are objections, we got one pull request against each one of these top 4 repositories. So unless there are objections, our plan is to merge these into the master branch. Then what you will do is in the Canvas charts, if you just go and install the Canvas, it will install Keycloak and Security Controller. So it, you know, if you've got a Canvas environment, and we will do this onto the ODA environment as well today. So you have the Canvas, and we'll put some notes just to show where Keycloak, where it appears. In the ODA CA docs, so I go into the merge is a merge of this example component. In the docs, we've updated the component design guidelines. So when you create a component, like this is showing the metadata you have to add. There's only one piece we've added, which is if I go down to the security section. So under security, it expects to see a party role API, and here you can put that party role. It can be implemented in any language, and you can have it appear anywhere in your component. And basically here you're explaining where the implementation of that party role appears, where the implementation is, and what path the API should appear. So you need to add, this is the only thing you need to add into a sort of a component spec. In the same docs area, if I go back up, we now have like an examples folder, and at the moment there's just one example component, which is the security component. And the security component basically has 2 microservices, one microservice offering the party role API, and another microservice offering the product catalog API. And then this is the Helm chart where they package it together as a single component. So there is an example component if someone wants to see the implementation, but these are based on the TM4 reference implementations. If I go back to the top, the actual source code, like the Python source code for the Python controller that we've contributed is in here. Like if someone wanted a deep dive, they can go and have a look at that source code. And then finally, there is the CTK. So the CTK, now when you test it, it looks at the component, and the component says whether it's version 1 or version 2. So when you create a new component, you label it as version 2, and the CTA will automatically test. In the static test, you've got this role section in the security area, and in the dynamic bit, it'll connect to the Kubernetes cluster, and it'll find that API, and it'll test that it actually works and gives back a party role. So that's so when we'll unless there are objections, we'll merge these 4 pull requests today, as they'll all be there in the master branch.
Very good. I'm interested in how different this is from the way that everybody's components are working today. Is it a big change conceptually? Is it quite a lot of work to do to to modify your components so that they pass this test?
For my side, currently, last week we have discussing with Lester, and he shared his experience about the controller, the Python script, and currently the difficulty in my side is to create this controller by the Python script and register it in the Kubernetes control services. So this is our key point. I am trying to fix this during this week, and I just say I'm trying. I'm not sure if it will be done inside this week, and will try to do this testing in the local test bed The another difficulty I met is to deploy on the ODA on the lab because the database, because in my local testbed we're using the MySQL, and in the ODA we try to use the MariaDB, so we have little bit configuration. And I also try to fix this during this week, and I will try to do this testing. And the T-Quark is still not trying. And currently, I just want to, how to say, to solve this several issues. One is the controller using Python script, and registered in the Kubernetes. And the another is to deploy with the new MariaDB. And I hope I can get some, how to say, success in this week.
Okay. Do you think 3 weeks is enough time?
I'm not sure. I just say I'm trying.
You're trying. Okay, very good. Thank you, Susie.
We had already additional resources to support me, and I will have an internal meeting tomorrow about to discuss about MariaDB, because previously one of my team member just leave the office for 1 week, so I have something delay about the database part.
Yeah, we had a session last week with the Well Cloud team talking about the API gateway and like the possibility of having someone like their own API gateway, the Well Cloud API gateway, and then like the pattern is identical. It's creating a control of that API gateway, but that controller is following this. It's called this operator pattern, and there are frameworks to help you create these controllers following this operator pattern. And the one we're using happens to be a Python one, but you can create the controllers in any language. Like all the Kubernetes ones are actually created in Go. But when I started this, I didn't fancy learning how to write stuff in Go. So
the language is not the most challenge, because the Python we are using other part inside our version. We have the developer who is familiar with Python. The difficulty is to register this into our Kubernetes control services. That is the challenge currently, because previously we're using other mechanism to manage the Kubernetes Docker applications, and we are trying now, and I hope we can make some achievement this week.
Great.
I had a sort of an AOB item if we're at that point.
Let's come back to that in a second, Dave, but I'm just wondering if anybody else is willing to express confidence that 3 weeks is enough time to get there. Richard, you're smiling. Are you confident?
Yeah, I'm not confident. We're certainly looking at it. We had a session with Brian and Lester last week to talk about it. We're not using the party role API, but we do have APIs, so there's no reason why we shouldn't, basically do the same thing to extract what roles are enabled in a component, and use that as part of, as part of the controller. So technically, I think it should be possible. It's whether we can do it in the time frame.
In the time. Okay.
But the question is, if you do it in the time frame, how much of it will be smoke and mirrors?
It'll be in Python, Lester.
That's the question.
It'll be a Python component.
Okay. How about anyone else? All right, it'd be great if we could have some others as well. So I think, our last show and tell, we had Oracle and Well Cloud passing the test. It'd be great if we could have one or two more as well. So let us know if you need help. Okay. Any other questions for Lester and Brian on the demo? Okay, Dave.
The discussion about intent-based interfaces has come up on the Autonomous Networks project, and I put in the chat window a contribution that came in from Netcracker on the various intent languages coming in from an autonomous networks point of view and a networking point of view. However, the discussion today on today's Autonomous Networks call was that they wanted to include intent-based mechanisms from sort of hyperscalers as well, because that's also important in this area. And if anybody's got any information on this, that would be quite gratefully received, you know, about what kind of intent languages are used by the major providers. The discussion this morning suggested that most of them are focused on natural language processing rather than some of the other approaches.
Yeah, there's a completely different use of the word intent, which have nothing to do with this content of the word intent. It's used in like, can I make structure from natural language? They call that you understand the intent of the natural language. That's almost like you need to separate that. That's a different technical challenge. This use of the word intent is much more, you know, from like a declarative approach.
Yeah, okay. So that's actually what's in the contribution today. You might want to have a look at it because it's quite a good summary of the activities and the different language approaches based on things like RDF, things like domain-specific languages, dynamic service descriptors, and things like that.
As an example, like this operator pattern we're following, there are lots of companies who've created operators for their own like domain, a domain language. And so you can buy, or you can get a, for example, an operator for AWS. So AWS have packaged their cloud services, so it's available in Kubernetes in almost like this native manner. It's called, I think it's called the AWS operator. IBM have done the same for their IBM, like their Bluemix cloud. I think Google have gone a bit further. They create something which is very, very similar to a concept of a component. They create something called a Kubernetes application, which is very, very similar to what we're doing here. So there's lots of examples of the hyperscale clouds doing this. Like this is what we're copying. Like they were first, we're copying what they're doing.
Okay.